this started off, basically when I put together notes, just sort of a summary of what we learned in the last chapter. So you want to know what rational functions are, the vertical asymptotes, horizontal asymptotes, and all that stuff. And then we're going to put all that together and learn how to graph these by hand. Okay, so I want to show you basically one thing on this. Just want to review this right here for a minute, this example right here, then we'll get into the graphing. So if you were going to find a vertical asymptote on this one, the first thing you'd have to do is see if this reduces. Okay, so of course the denominator factors is x plus 6, x minus 6. So let me ask this question. How many vertical asymptotes does this have? 1 or 2? 1. Only 1, okay? What happens, remember what I showed you before, is the one that cancels out gives you the whole. The one that's left over is the vertical asymptote. Okay, and you can do this in your head. The vertical asymptote is x equals 6. The whole is at x equals negative 6. Okay, so we'll look at a couple of graphs like that in a few minutes where you have a hole in the graph like that. So you want to know that. When you're doing a vertical asymptote, be sure you simplify first, okay, and distinguish between the hole and the asymptote. All this stuff right here is a review of the rules. I'm going to do just a really fast kind of review on this then. What this is an example of the horizontal asymptote. If the degree of the top is less than the degree of the bottom, then y equals 0 is your horizontal asymptote. The second case was if the degrees are the same, in this case 2 and 2, then the horizontal asymptote in that case would be 5 over 2. Okay? And then the last one would be the degree is 1 bigger, so that would have the oblique asymptote. I'm not going to take the time to find that, but it has the oblique asymptote like that. So when you're doing your horizontal asymptotes, just do your rules because it's fast. Okay, and one of the three things is always going to happen on your rational function. Okay, all right, all that is on the first page is a summary, kind of what we did. And now on the next page, we're going to start looking at some graphing examples. Yes?
How do you know that x plus 6 is the whole and x minus 6 is the vertical?
Okay, basically it works like this. What you would find on this is since this cancels out, you would end up getting really 1 over x minus 6. If you graphed 1 over x minus 6 on your calculator, it would have one asymptote. It's only one place where it's undefined. But the original function is actually undefined at 2 places. X can't be 6 and it can't be negative 6. The one that canceled out is the whole. So what I did, and I did that in my head, I just did x plus 6 equals 0, therefore that hole's at negative 6. So it's the one that cancels, okay? What you would find if you graphed the original and this, those graphs would look exactly the same with one exception. The graph of this would have a hole, the graph of that wouldn't, okay? That's the idea. So it's undefined in 2 places.
Okay, thank you.
Okay? Okay, so let's go ahead. We're going to put together a graph now on this. So when you do a graph of a rational function, I'm going to show you how to do this totally without a calculator, right? And just kind of for the analysis part and the understanding part of this. Okay, first of all, can you tell me by looking what the horizontal asymptote is?
2.
It's 2, right. Okay, the degrees are the same. Okay, so the highest power is the same. So the answer to that horizontal asymptote is right there. So you would get y equals 2 over 1, or just y equals 2. Okay, so we have that. Now when we start doing our graph, we'll kind of start with the asymptote. So we got that. Okay, now when you do the vertical asymptote, one thing that you want to do is see if you can simplify this. You really can't simplify it. You can factor a 2 out of the top, but nothing's going to cancel anyway. Okay, can you tell me what the vertical asymptote is just by looking? X equals 1, right. Okay, the vertical asymptote is what makes the simplified rational function's denominator equal to 0. Okay, so we got that. We've got our 2 asymptotes. That's the way you should always start these problems, is just get the asymptotes out of the way and get those put together. Okay, so what I want you to go ahead and do now is go ahead and go to the graph I provided for you and just sketch out your vertical asymptote and horizontal. So the vertical asymptote goes through x equals 1, use a dashed line there, okay, like that. And then also do the horizontal asymptote, which was what, y equals 2. Okay, so that's kind of an important way to start a rational function, is find the asymptotes if there are asymptotes. Sometimes there aren't asymptotes. Okay, so that would be what you'd want to do to start. Okay, now we want to get into the intercepts. So you're now starting to kind of get what happens on with intercepts and so forth. So I'm going to do this kind of at the side here. So to begin with, when you do the y-intercept, what do you always do when you get a y-intercept? X equals 0. That's always easy to find an x-intercept. A lot of times you can do that in your head. So you would just do f of 0, which is 2 times 0 plus 6 over 0 minus 1. Okay, nice thing on that, that cancels out. You got 6 over negative 1, therefore it's negative 6. Okay, so your y-intercept is going to be the point 0, negative 6. Okay, and what will happen on this then is you want to go ahead, just go to your graph and put a dot down on negative 6. I can hardly see those numbers, so that's down on negative 6 like that. Okay, got a point. Okay, if you can get intercepts, you want to do that. Okay, so now we'll do the x-intercept. So the x-intercept, what you always do is you just take the original function and you set it equal to 0. And now the thing about the x-intercept is if you had to reduce, then you would set the reduced form equal to 0. Okay, and you can do a shortcut on this one. This is an equation with a fraction in it, so you could go through and do this, but I can show you how you can bypass all this in just a minute. What happens is, really, you can always get by just setting the numerator equal to 0 on an x-intercept for a rational function, because you're just going to get rid of the denominator anyway when you solve the equation. So if you solve this equation, that's 2x equals negative 6, and then divide by 2, so you end up getting x equals negative 3. Okay, so you have a y-intercept at negative 3, 0. Okay, so we want to go ahead and put a dot there. Okay, so what I've done so far is I've got the asymptotes, which is not a very hard thing to do, and the intercepts. X-intercepts sometimes can be a little complicated depending on what your rational function is. Okay, now we're going to bypass the calculator, and what I'm going to teach you how to do next is a sign chart to figure out how the graph goes. Okay, because I'll explain kind of what happens on asymptotes as we go on this. Any questions so far with what I've done? Okay. All right. Now here's what we want to do on this. So on the sign chart, what I want you to do is just draw a number line. And you're going to do a lot of sign charts in Calc 1. So what you want to do is you want to do the vertical asymptote. What you always do is you locate the vertical asymptote and x-intercept. Okay, so we had a vertical asymptote at 1 and an x-intercept at negative 3. So put a 1 there and put a negative 3 there. Okay, now it's real important when you make your sign chart, all you worry about is 2 things. You worry about vertical asymptote, and then you worry about x-intercept. That's it. Okay, and then you're going to kind of subdivide this, and you're going to analyze with what we call test points on this. Okay. And what's going to happen on this is we're going to look at the function that we're graphing. So we just got through, we're working on the function 2x plus 6 over x minus 1. So you're going to take test points and plug in there. And it doesn't matter what the point is. So all you got to do is pick a number less than negative 3. Negative 4 is a good choice. Keep it as simple as possible. Okay. Now plug in to your function. So you're just going to plug in, so you have 2 times negative 4 plus 6 over negative 4 minus 1. You can work that out if you want to, but I never do. All I do is this is what I do. If I look at the numerator, I have negative 8 plus 6, so it's a negative answer. I don't care that it's negative 2. All right. If I look at the denominator, negative 4 minus 1 is negative. I don't care that it's negative 5. Because the idea is, what is a negative divided by a negative anyway? It's a positive. Okay, so you want to get that result, and it turns out that in this function, any number you choose that's less than -3 is going to produce a positive function value. That's the idea. That's a test value. Okay? Okay, then I go to the next interval. I pick a number between -3 and 1. And I always pick 0 if I can, because that's the easiest number there is to calculate with. So again, I plug in to the function. So I just do 2 times 0 plus 6 over 0 minus 1. And most of this stuff you're going to learn to do in your head. Okay, this is just a positive 6 over a -1. So it's a negative result is what you get. Okay, so no matter what test point you use there, you'll get a negative result. Okay, then we go out to the last one. We pick a number bigger than 1, say 2. Again, plug into the function. So that's 2 times 2 plus 6 over 2 minus 1. And I think you can see in your head that's positive, right? So you don't have to take the time to work out the arithmetic. Usually if you just plug the number in, you can usually tell if it's positive or negative, and that's good enough. Is everybody with me on what I did there? Okay. All right, now the reason that we do this is because of this now. So what this means, if this is positive, that means your graph is above the x-axis. And that's all that matters, really. And if it's negative, that means you have negative y values. See, all we're doing is we're looking at are the y values plus or minus. Therefore, are the y values above or are they below? Okay? So now you can put this together like this on your graph, and this is what you have to understand. Okay, according to this problem, this is what this says. When you're to the left of -3, all of the y values are above the x-axis. But what's going to happen is, since you have a horizontal asymptote, it's going to go like that. It always approaches the horizontal asymptote. It's not going to go like that and then loop around. It's going to go like that. It always does that on a horizontal asymptote. So that means that this part of the graph, all you got to do is just sketch it. And it's pretty accurate by doing that. So that takes care of that part right there. Okay? Then the next thing is between -3 and 1, all of the y values are negative, right? So you have to go like this. Okay? And what you always do, if you have a vertical asymptote, you're always going to get close to it but never touch it. Okay? So it goes like this then. This part of the graph would be all below the x-axis, but make sure that you just draw it so it approaches the vertical asymptote like that. That's the idea. Okay? And then the next thing that happens on this one is when you're bigger than 1, according to our sign chart, when we're bigger than 1, you're up here. Well, the only way that this can happen is like this. Okay, if you're above, it's got to go like that when it gets close to the vertical asymptote, and it's got to level off like that. You can't do anything else. Anytime you have a vertical asymptote, the graph either goes to infinity or negative infinity. So what will happen is you just sketch the shape, and then you got it. If you put that in your graphing calculator, that's what you would see. Okay, that's pretty accurate. You know, you can make it more accurate by getting points, but that's kind of the idea of what I want you to be able to do, is to put that together like that. Okay, that's the sign chart. That's how you analyze that when you put that together. And then a couple other things on this that will go through the domain. On this problem, the only place that you're undefined was at 1. So your domain, you could just say in set builder, you could just say set of x, x is not equal to 1. The range is everything except 2. Okay, if you look at the graph, it never touched the horizontal asymptote, so the range, you could say set of y is not equal to 2. Okay, so that'd be kind of the idea on that. The range, you have to look at the graph to kind of analyze and figure out how that goes. So you're not equal to 1, and then your y is never equal to 2. Okay, does that make sense what I did? Well, it's easy to put these in the calculator and do it that way, but I want you to understand the math behind it, because that's real important. Okay, you go to calculus, you need to understand stuff at a pretty good level. Okay, let's go ahead and let's do one more problem, then we'll take a break here after this next problem. Any questions about what I did? I'm going to do on these other examples, it's going to be kind of going through the same type of thing, but there's going to be little nuances of the problem as we go, little differences. Okay, so let's take a look at this one then. All right, the degree of the top is 1. The degree of the bottom's 2. What does that tell you about the horizontal asymptote? Y equals 0. Okay, you want to get those rules memorized. Okay, so we got that. All right. All right, the vertical asymptote. Well, what do you do to find the vertical asymptote? What do you look at? Denominator, and figure out what makes the denominator 0. You can do this in your head, and sometimes these problems you can do in your head. So you just solve that equation. Okay, that's plus or minus 2. You do the square root property or factor, so you just get x equals plus minus 2. So your vertical asymptotes are going to be, and you can write plus minus 2 if you want to like that and abbreviate it, so you got that. Okay? All right, so we got the asymptotes out of the way. That's usually a very simple process to do. So go ahead and go to your graph and do your asymptotes. Okay, so I'll put the vertical line at 2. And then I'll put another vertical line at -2. And then if y equals 0 is an asymptote, that just means the x-axis is. So y equals 0 is the x-axis. Okay, so that's our asymptotes that we have right there that are an important part of the graph, okay? Okay, now what we're going to do is going on to the y-intercept. Okay, the y-intercept, we always just set x equal to 0. Okay, if you do this, if you do f of 0, you're going to get 0 over 0 squared minus 4, that's 0. Okay, so you end up getting this then. Now, one thing I want to mention on this is if you get 0 as your y-intercept, that's also an x-intercept, isn't it? So really what you can always do when you find an x-intercept, really all you ever got to do is just take the numerator and set it equal to 0. Okay, but if you get 0, 0, that's both an x and y intercept at the same time, so they're both the same. Okay, so we got that. So the process of finding intercepts is always the same. So essentially what we do in the problem is you get your asymptotes, you get the intercepts. In this case, we only have one intercept. So now we're going to go to the sign chart, and the sign chart will tell you how the graph behaves around the asymptotes, essentially. That's the idea. Okay, so any questions so far with anything? Okay. All right, let's see. So on the sign chart, now you want to make sure that you always get the sign chart set up. On the sign chart, you want to do two things. You want to use the x-intercept, and you want to use horizontal asymptotes. You don't look at anything else, just those things. So when you draw your number line, let's see, we had this. We had a horizontal asymptote at -2, we had an x-intercept at 0, and we had another vertical asymptote at 2. That's what matters in the problem. Nothing else does. Yeah. Go ahead. You have something?
Aren't those your vertical asymptotes?
The teacher wrote the wrong thing. Yeah, it's vertical asymptotes. It's anything that goes through x. Okay, so that's x-intercepts and vertical asymptotes, not horizontal. That doesn't have anything to do with what we're doing right now. Okay, so break it up. And then again, we're just going to do some test points on this. Let me write down what that function was. So it's x over x squared minus 4. Okay, and then we're just going to plug in test points into x over x squared minus 4. You don't have to do all the details of the arithmetic, just enough to figure out if it's positive or negative. So I'm going to start with -3 as a test point, something less than -2. Plug it in. What you would have is -3 over -3 squared minus 4. That's a negative numerator. The denominator is 9 minus 4, so it's positive. Okay, do as much of that in your head as you can. If you need to work through all the steps, that's fine. So a negative divided by a positive is a negative. What that will mean is you are below the x-axis at that part of the graph. Okay, it's arithmetic. When you do a sign chart, it's kind of a pain to run through this, but it's arithmetic. It really is. Let's go here. What's a good test point there? -1. Okay, right. Okay. So we would have -1 over -1 squared minus 4. That's a negative numerator. That is a negative denominator. So a negative divided by a negative is a positive. Therefore, you're above. Okay, like that. And the signs often alternate. They don't have to alternate though. So don't assume they're going to alternate. I see students do that all the time. So the next one, go to 1. Plug in. You would have 1 over 1 to the second minus 4. That's a positive numerator over a negative denominator. So that's a negative. Therefore, you're below the x-axis. Okay, and then the last one, go out to like 3. Plug 3 in. That would be 3 over 3 squared minus 4. That's a positive numerator over a positive denominator. Therefore, you're above. Okay, now I crunch out these sign charts. I'm going to start doing them pretty quick here. But does everybody understand what I'm doing with the test points and the sign chart? That's a big, big deal in calculus. You'll do sign charts all the time for different reasons. Now, once you get that sign chart put together, then this will tell you how the graph behaves. Okay, so this is what you got to look at. When you're less than -2, when you're in this region, you're all below the x-axis. So what's the graph going to look like? Well, it's got to go down to approach the asymptote there. Horizontal asymptote is going to approach that way. So you're going to kind of go like that, and then you just connect. Okay? Now all I'm having you guys do on this is a sketch, a very rough sketch. So all you need to really do on this is just kind of go like that. You know, that graph's going to go like that, and then just kind of connect it into that shape. That doesn't have to be perfectly accurate to me. I just want the shape there, and that's what's going to happen. Okay? The next part is between -2 and 0, you're above. So that's this little region here. So the graph's always going to be above, so it's going to approach the vertical asymptote and go to infinity. So this part of the graph, you just do this. Make sure it doesn't touch the vertical asymptote, but just show that it's getting close to it. Okay, so that takes care of that part. Then the next part is below. So between 0 and 1, you're below. So you just do that. Okay, and then finally the last part, you're above. So in this region, once you get past 2, you're above. So that would go like that towards the horizontal asymptote, and then you just connect like that. Okay, and that will always happen on that. Anytime you have a vertical asymptote, the graph gets close to it and goes to infinity or negative infinity. You want to know that. If you have a horizontal asymptote, that just means as the graph gets infinitely big or x gets infinitely small, it levels off at that asymptote. If you put that in your calculator, that's what you would see. Okay? All right, so let's see. Domain, the only thing that x can't be is plus or minus 2. So your denominator, it can't be plus or minus 2. So domain, you can just say set of x not equal to plus minus 2. Okay, how about the range? Look very carefully at my graph. What do you think? It's everything, all real numbers, okay? Yeah. One thing that students oftentimes get confused about is you can touch a horizontal asymptote. You can't touch it way out there and way out there. But anywhere in between, you can touch it. Okay, it's okay. So it does cross because we had an X-intercept. So the range would just be, you could say, in interval, you could just say all real numbers. Okay, like that. And so you can touch the horizontal asymptote, just not at infinity. That's the idea.
That's kind of tricky.
Yep, but you can't touch a vertical asymptote. The reason you can't, because the function's undefined there. Okay, so you can't ever touch a vertical asymptote. Okay, any question about what we're doing? Okay, all right, let's go ahead and take a break. Just come back at 9:10. I'll give you a little more than 5 minutes. And I think some of you may not have got your test back, so if you didn't get your test back, you've got these up here.
What class are you using to take card for?
What's that?
What class are you using to take card for? That book? Did they get card? You lost? Cool. You lost?
I got several papers. I think I didn't bring yours again. I got to get yours outside, but I had to print it out is what I did. And I don't think I brought it with me. I remember I thought about this morning, and then I didn't remember again. So I'll do my best. One thing you could do is you could also email, because I think what I did was since you did it since they sent it to me electronically, I just put it in OneNote and read it electronically. So I did that. So I could
just send
That's all
you
it's
that.
gonna cancel.
If you want me to, if you send me an email, it may work printed out, it doesn't make any difference, okay? But I need to get that to you so you know what to do. I don't remember what you scored. Okay?
But the way how he explained it in here is like once you have a y-intercept at 0, it's gonna be the same thing as the x-intercept. So that's gonna short cancel.
Going on this, there's two more examples I want to show you. This is the one that if you're not careful about, and you might make some mistakes on it, because I think this one's probably got a hole in it, and you have to be kind of careful when that happens. So really the first thing is, the horizontal asymptote's real easy. So if you look at the degree of the top is 1, degree of the bottom is 2. Since 1's less than 2, y equals 0 is your horizontal asymptote. Okay, so that's going to be automatic to you. Now the vertical asymptote you have to be very careful about. What you need to do is notice you got some factoring in this. So you want to start this way. The numerator you can factor a 3 out of. So you'd have 3 times x plus 1. And then the denominator, if we factor the denominator, you're going to have x and x to get x squared, 2 and 1 to get 2, and then a minus and a plus like that. Okay? So I'm going to ask the question again. We've done this a couple of times. How many vertical asymptotes do I have? 1 or 2? I have 1, right? Okay, what happens is this one is the whole. So x plus 1 gives the whole, but the one that's left over gives the vertical asymptote. So you would end up kind of working with x minus 2 equals 0 to get the vertical, and x plus 1 equals 0 to get the whole. Okay? So what you'd end up having is that would be x equals 2, and then the whole would be x equals negative 1. Everybody got that? Okay, that's important. This is a big deal in calculus. At the beginning of the semester, too, when you talk about limits, you'll see these wholes and asymptotes in graphs all the time. Okay, so we got that. So the next thing is the y-intercept. Y-intercept's always easy. It's an arithmetic problem. So you just set x equals 0. So a lot of times you can do this in your head. I don't mind on this if you just do this in your head. So that's 0 squared minus 0 minus 2. You would end up getting 3 over negative 2 if you work out the arithmetic. So the y-intercept is 0, negative 3 halves. Okay, so we've got that now. Okay? When you're doing the X-intercept, be very careful about this. This is a place where students often really slip up on. What you want to do is you want to use the reduced form. I would write a note down on this when you do this. Use the reduced form. Okay, don't use the original. What I've been saying is in general you can set the numerator equal to 0 to find an X-intercept on a rational function. That's not always the case. You want to use the reduced form because one of those things ended up canceling out anyway, where you had that whole. So what we're going to do is we have 3 over x minus 2. That's the reduced form right there. And you're going to set that equal to 0. Okay, you always set the function equal to 0, but make sure it's the reduced form. Then you solve the equation. Okay? Now, you may be able to do this in your head, maybe not. I don't know. I can tell what it is. If you just multiply both sides by x minus 2, kind of a weird thing happens. What you would get on this is you would get 3 there equals 0. Okay? All the variables cancel out. What do you think that tells you about your x-intercept if you get some bizarre statement like that? You don't have one, exactly. Okay, you don't have one. So you're going to find on this you don't have an x-intercept. Okay, eventually we'll put this in the graphing calculator and I'll show you that. You'll visually see that it never crosses the x-axis. So again, the thing that's real important is reduced form. That's what sets equal to 0. And sometimes you won't have an x-intercept. That will happen sometimes. Is everybody with me there? That's a little tricky detail of the problem that you have to pay attention to. Okay, I'd write down that reduced form because that's a big deal. All right, so here's what we're going to do next here to kind of put this together. We're going to go ahead. I'll have you put your asymptotes on there. So we always want to start there. So we had a vertical asymptote at x equals 2. So you want to go ahead and get that sketched. And then we had a horizontal at y equals 0. Okay, and then we had, I think we had a y-intercept, but we didn't have an x-intercept. And then on the sign chart, I'm going to teach you how to cheat. Okay, this is actually important to show students how to do a sign chart on a calculator. So I'm going to do it that time. I'm going to do it this on the calculator this time. Okay, so what the other thing is, we got our asymptotes. -3/2 is like -1.5, so you just kind of estimate where that y-intercept is like that. Okay. So I'll show you kind of what we can do on this now as far as doing a sign chart. Now this is real important when you do this sign chart down here, is what I always said is to use what two things. I said X-intercepts, and I said wrong a minute ago, so it's vertical asymptotes. So you always only use those two things. We don't have an X-intercept. We do have a vertical asymptote of x equals 2, so it turns out on this problem that all that matters is 2. That's it. Okay? So what'll happen on this, actually this is easy, I'm just going to do the sign chart, it's faster to do it without the calculator on this. So you can use the reduced form too. And that's another good thing to write down, because it'll work either way, but the reduced form simplifies your sign chart. So if you have a reduced form, work with that to do your sign chart, and work with that to find your x-intercept. All right, let's just kind of crunch this out like this then. So what we'd have is, let's use 0 as a good test point there. I like 0. So we'd have 3 over 0 minus 2. So that's a negative number, okay, because that's a positive 3 over a negative 2. That's negative. That means the graph is below the x-axis, okay? Use a test point bigger than 2. We could use 1. So we'd have 3 over 1. I'm recording too. That's going to be really a good thing there, okay? Can you help me out and give me a number bigger than 2? How about 3? Is that better? Okay. That's the kind of stuff I mess up on. So it's like 3 over 3 minus 2. So that is a positive. So you're above the x-axis like that. Okay? All right. So that's what we have. Now, see, what you could do from here is you would know what your graph looks like based on this sign chart once you catch onto this. So the idea is, when you're below in this region here. So what the graph's going to have to do, it has to go like that, and it has to approach the vertical asymptote. It has to. And then it has to level off towards the horizontal asymptote. So that's how the graph goes. That's really reasonably accurate. When it goes above, when you're above 2, then what does it got to look like? It's got to kind of do this thing. It's got to go to the asymptote and level off. So you got to know the shape of that, see? Okay, so what would happen here is, kind of goes like that, kind of goes like that, and then just sort of sketch it in like that. Now, I'm okay with a rough sketch on that. That's fine, okay? So there's one other detail of the problem that you have to do, and that is we had a hole. I forgot where the hole was. The hole was at x equals -1. Okay, so here's what you can do on the hole. You can plug the hole in right there, and what you end up getting is 3 over -1 minus 2. So that's 3 over -3. Therefore, you have a y value at -1. So what it means is, if you go to the point -1, -1, you just put a open bubble there. So that's what I'm going to do here, is kind of go to -1, -1. And then you got to put the little hole there. You have to put that there. That's a part of the graph. So what I did is, notice I put the value of the whole x equals -1 into the reduced form, because if I put it into the original form, it'd be undefined. So that's why that happens. So what happens is, you're getting close to that hole. It's getting close to a y value of -1. So that's how that happens. Okay? All right. So let's finish this problem up by putting this in your calculator. This has got enough going on in it, but I think it's pretty helpful to just do this on your calculator. So the way I would check this and verify is, I would put the original in the calculator. Okay, so, and put the original in, because you won't see the hole unless you put the original in. So it's 3x plus 3. Divided by x to the second minus x and minus 2. And just do that in a standard window. So I want to see if you see basically what we came up with. Ah, look at that. See? Let's see how accurate it is. Okay. Now the only thing that happens on this, you don't see the hole. I haven't seen any calculator that shows the hole. But if you trace at -1, you want to try this. Trace at -1. What'll happen is it'll show you that you're undefined there. So it'll just say y is nothing because it's undefined. So that does mean that there's a hole there. That's the idea. So see, you can always, when you're doing this graphing, you can close the deal off by looking at your graphing calculator. But when you're doing your homework, if you want to learn this the way I would like you to learn it, don't use your graphing calculator. Okay, because my math lab is going to be usually multiple choice on these graphs. You could put it in your calculator and always get it right and never learn anything. Okay, on your next exam, non-calculator part, I'd have you do this sign chart because I want you to understand how things work. Because you need to, for calc, you need to have an understanding of how the math works behind this. All right, is there any question about anything I did there? That's the one that's the most complicated to me, is the one that has a hole in it. There's some little nuances of that you have to kind of pay close attention to. Okay. All right, for the domain on this now, there are 2 places we're undefined. Remember, you had a vertical asymptote at 2, and then you had the hole at -1. So you could just say set of x is not equal to -1 and 2. I think most of the time on my math lab, if they want you to do that in Set Builder, that you just kind of fill in the numbers where you're undefined on that. How about the range on this? Just look at the graph. What does it look like the range is on this? It never hits 0, okay, on that. Now, you got that hole on there, too, which makes this even a little more complicated. There's 2 things that happen. Y is not equal to 0, and y is not equal to -1. Okay, now remember, this is the part right here sometimes students get confused on. We found the hole at -1. We plugged it into the reduced form to find that y value. So since there's a hole there, y will never be -1 either. So you've got to pay attention to that really closely. So for your range, you would say set of y is not equal to 0, because that's the horizontal asymptote, and it clearly never touches the horizontal asymptote, but then you got that hole. Okay, that's why it's important to see what the y value of that hole is going to be. Okay, because in this case, it's not going to be -1. All right, are you with me there? See, this problem's got all kinds of little nuances in it that you have to be really cautious about when you do this. Now just follow what I'm showing you to do on there, and you can be okay, because mostly what we're doing is arithmetic processes on here. All right, so let's see. One last one. I want to do one on the next page, and then the one on the last page is just something I want to show you on the calculator. So, and then that'll wrap this up. So I'm just trying to show you really kind of like one of each thing that can happen on these, the main things. So this one's a little different. So with this one, look at my function. Can you tell me what the horizontal asymptote is by looking? No response. What? Nobody's even shaking their head. What is it? We don't have one. Thank you. Okay. Remember, what happens is the degree of the top is 4. Degree of the bottom is 3. So that means we don't have one. And you may not have the rules memorized yet, but that's what you're going to be working on. Okay. So you know you don't have a horizontal asymptote. Okay. Do we have an oblique asymptote on this problem? Yeah. How come? Because the degree of the top is 1 bigger. Okay, so we are going to have to do that long division. We have to do that. Okay, all right. I'm going to bypass the vertical asymptote for a minute and show you, because I suspect on this you have to use your graphing calculator to even find it anyway. Okay, so let's go down to the oblique asymptote. Unfortunately, this one we have to do long division on. Okay, but I'll kind of bypass a few things on this as we do that. So what you want to set up, and just kind of do this down in this area, you're dividing by x to the third minus x squared plus 1. And I think it's pretty helpful if you put all those missing terms in that numerator. So we'll have 3x to the fourth. We don't have an x to the third, so, have a space for that. We have minus x squared plus 0x. Now, you don't have a constant term, so you can put a 0 there, although it probably won't make any difference if you bypass that anyway. So we're going to get that thing set up, okay? Now, I'm going to try to, again, sort of write steps as I go. You can write steps if you want to, so you always start on these problems like that. That's step one, is to do that division, which once you practice this, you'll start doing this in your head quickly. You really will. So that is just 3x, okay? And that's already the first part of our answer. Remember, if it's an oblique asymptote, it's going to have the structure mx plus b. If we can find that b part, we're done, okay? So sometimes you don't have to do the whole division on these problems anyway. Second thing is you take the 3x and you distribute it through the x cubed minus x squared plus 1. So that's going to be 3x to the fourth minus 3x to the third plus 3x. And you just record that under the like term. So I put the 3x to the fourth there, the 3x to the third there. Don't have anything there, so this is going to line up as a 3x like that. Okay, that's why I like to kind of have placeholders for the missing terms. I find that the most common place students mess up is step 3 when you subtract. You just got to pay attention to what you're doing. So 3 minus 3 is nothing. That always happens if you do your division right. The next one you got to be careful about. What you're doing is you're doing 0 minus minus 3, right? So that is 3x to the third. If you slip up on that, it'll mess up your asymptote, okay? All right, now what we're going to do on this, you can bring down the next numbers, okay, on this, so that just kind of comes down. If you subtract this, because I'm subtracting, that is 0 minus 3, so that's negative 3x, and then you can bring down the 0 if you want to, but you don't have to, okay? Now, I've only got one more thing to do, is I just need to do one more division, and then I'm done, okay? So now what I'm going to do is I'm going to divide these two things right here. Okay, and I'm just going to do that in my head. I'm starting over again. And all I got to do is this, then I'm done with the problem. Okay, so what is that? Plus 3. Problem done. Okay, you do not have to go any further. Don't even waste your time. Okay, it's not necessary. Okay, once you get those two things, then you're okay. I showed you a minute ago why you don't have to go any further. That's just because of the remainder is going to end up going to 0 anyway as x goes to infinity. So that is your oblique asymptote, okay? How do you feel about that? That's usually something that's a little challenging to learn how to do for some students. Now come by if you need a little help with that, because you'll do that a little bit. Let's go ahead and graph that. You don't need a calculator to do that. That has a y-intercept of 3. And then it has a slope of 3 over 1. So if your slope's 3 over 1, you're just going to go up 3, right 1. And you can do that, several times if you want to. It doesn't really matter. Okay, just kind of get, and use a dashed line to represent that oblique asymptote. Okay, like that. All right, so we got that. So that's all we've done so far is we got that oblique asymptote. And you have to do that typically by doing long division. So now we're going to focus on the intercepts, and I'll get back to the vertical asymptote in a minute because you have to use technology to figure it out, okay? So let's go ahead and let's do the x and y intercept here. Okay, so y-intercept should be able to pretty well do in your head. So you just do f of 0. And most of the time, you're going to do the y-intercept in your head. I already know what it is. Okay, it's 0, right? Okay, if you set the x equal to 0 in the bottom, you're going to get 0. If you set it equal to 0 in the bottom, you're going to get 1. So you don't have to necessarily write that out. So your y-intercept is just the point 0, 0. Okay? Now, I said this a minute ago. I said the point 0, 0 is also an x-intercept, right? So if you get that, then that's your x-intercept. Okay, the other thing that you got to do, though, and this problem will get a little bit weird on this, is you have to technically, when you do the x-intercept, you have to set the numerator equal to or the reduced form equal to 0. Okay, now the bottom doesn't factor. That's why we have to use our graphing calculator to find the vertical asymptote, which is what we're going to do here in a minute anyway. So what will happen on this is you could multiply both sides by that denominator to get rid of the fraction. And you can just sort of process that in your head. So really all you ever have to do is just set the reduced form equal to 0, and then you can factor this to find this. So if you factor out an x squared, you would have x squared times 3x minus 1 equals 0. Okay, I'm just setting the numerator equal to 0 and then solving that way. And then we're going to get a couple of things on this. We get x squared equals 0. We can solve. And then we have 3x squared minus 1 equals 0, and we can solve that. Okay, so this one is going to give an x-intercept of 0, which we already figured out anyway. And then this one, you're going to have some square roots in it. So this one, you would add 1 to both sides. So you get this. And then we can divide by 3. So we get x squared equals 1 over 3. Then you square root both sides. So you would actually get, and you have a plus or minus on this because we did the square root property. The square root of 1 is 1, so you'd have plus minus 1 over root 3. So those are also x-intercepts on that. So your other x-intercepts are going to be 1 over root 3. You don't need to rationalize the denominator. And then you would also have negative 1 over root 3, 0 like that. Okay? This problem just getting messy, but it's the same general kind of process that we usually do. Okay, are you with me? Okay. Okay, all right. Well, it gets a little bit messy with the algebra on this. Now, what I would recommend that you do is just let's do this on the calculator. I mean, I don't know what the decimal of that is, so I'm just going to go 1 divided by square root of 3, just to get an idea of where that is. It's some decimal, so I'm just going to write a note to myself. Whoops, that thing was 0.5, I think is what that was, about 0.6 or something like that. Okay, so I'm just going to write a note to myself that that's roughly 0.6 and negative 0.6. Okay, so what you're going to do is just put a little tiny x-intercept in there, kind of like that, something kind of like that. Okay, that's good enough. Now what we're going to do on this problem is we're going to do the rest of it with the graphing calculator. Typically, if you have an oblique asymptote, I usually prefer that a student just does this on a graphing calculator because it gets kind of complicated. So if I was testing over this, this would be something I'd allow you to use a calculator on because it gets kind of complicated in this situation here. So let's go ahead and put the problem in the calculator, and then I'll show you how the sign chart will go if you crunched it out by hand, but you can kind of bypass that with your calculator. Okay, so go ahead and put the function in. And there's a couple of more things that we'll do on this. So we got 3x to the 4th, and then minus x to the 2nd, and then divide by, let's see, x to the 3rd, and minus x squared plus 1. Just doing a standard window. And we may have to adjust that a little bit. So once you get in zoom 6. Let's see what we got here. Okay, can you see kind of how the oblique asymptote goes? Can you kind of see it in the graph? See how it's kind of slanting? Okay. So what we're going to do on this then is you can tell we have a vertical asymptote there also. You can tell that. So we're just going to kind of approximate where that is. I'll show you how to do that in just a minute. So it looks like that vertical asymptote is a little bit less than negative 1. I'll show you exactly what it is here in just a minute. Let me get this calculator set up so it doesn't close off here. So just kind of put an asymptote pretty close to negative 1 on your graph. Then the rest of it we're just going to sketch. Okay, but I'll kind of show you kind of what happens on this if you did a sign chart when you did this then. And I'll also show you in a minute how we can precisely get that intercept with our calculator. So that's what we got so far. All right, now what I want to do next here is I want to talk about what the sign chart's going to do. I want to talk about that, but I'm going to do a couple of things on the calculator. If you're doing your homework and you're kind of in a pinch for time, sign charts can take time, you can do them on your calculator. As long as you understand the process of how to do a sign chart by hand, I'm okay on your homework if you just kind of use your calculator to figure that out. Okay, so remember I said X-intercepts are important, and I said vertical asymptotes important. Okay, so what we're going to have is we ended up having about, let's see, our X-intercepts were 0, around negative 0.6, and around 0.6, like that. And let's see, with vertical asymptote we hadn't found yet, so it's somewhere roughly around -1. Okay, so what I'm going to have you do is put, like, technically this is -1 over root 3. Out here you have +1 over root 3. Then you have a 0 in there, and then you have that asymptote, which we'll figure out here in a minute. So I'll show you how to do that. All right. So I'm going to just put roughly -1 for now, and then I'm going to show you what you could do on the calculator to analyze how these signs go. And then the rest of it we're just going to make a rough sketch. So this is mostly a technology problem. I want you to look at kind of how these work out when you're using technology. So I want to show you how you can do this sign chart on your calculator. Yeah.
When you want your -1 to be past.
What's that? I'm sorry?
When you want -1 to be past your -1 over.
Thank you. Thank you. The teacher's putting things on the wrong order on the number line. Okay. It looks like you can tell the vertical asymptote is to the left of where that X-intercept is. Okay, so that would be, you put the -1 over root 3 there. Okay, now remember, this was like, I think when I did this on the calculator a while ago, that was about -0.58. That was about 0.58 like this. Now, here's how you can do a sign chart on your calculator. I mean, you can tell by the graph, but you can just trace out your test points. So let me show this to you. I'm going to take -2, and I'm just going to trace -2. Just make sure you have a good test point. Okay, got a negative number. Okay, all right, so I don't have to calculate anything. If you get into a time crunch on your homework, you can do your sign chart this way. Okay, now I'm going to take a test point here. Let's take like negative point, be safe. Let's say -0.6. Okay, so I'm going to trace at -0.6. Okay, and then that'll give me a positive. See, I couldn't really tell by the graphing calculator, but I can now. Now I'm going to go from a test point in here. I'll do something like -0.1. So I'm going to trace at -0.1. Just be confident that you know where you are. That looks like that's a negative. So it's going like that. Okay, I'm going to go out here. I'll do like 0.1. So I'm going to trace at +0.1. And that'll give me a negative also, which is kind of hard to tell on my graph, but it looks like that's negative. And then finally, the last one will be positive. So if you did something like 1 as a test point out there, then you'll get a positive. So you can actually trace your test points and do your sign chart that way. And that way you're kind of checking the graph at the same time. Okay, so I just kind of, since it's decimals, I just used decimal values and traced it on my calculator. All right, so I'm going to show you one more thing, and then we'll kind of then we're just going to sketch the rest of the problem like that. So this is what I want you to do on this. From here, all we're going to do is sketch. So you can kind of tell that in this region, you're below here. So when you're below that first thing, it's kind of going like this. So you can just sort of roughly sketch how this shape is going there. So that graph's clearly doing something like that. What it's doing here is on this side. And let's see, I've got the asymptote there. This is kind of weird what happens here. This thing kind of does something like that. You have a y-intercept of 0, so it kind of goes down below kind of like that. Then this graph kind of squeezes up in like that. And actually what happens on this is it has to kind of go like that towards that asymptote from the right-hand side. That's kind of weird what happens on that, but that's how it happens. Okay? All right? You guys are a little confused on this one, it seems. That's what I'm sensing. This is a little bit more complicated. All right, I'm going to close this off with one other thing. I'll show you how to find the vertical asymptote. Because sometimes you have to use technology to do the vertical asymptote. Okay, so what I would do to find the vertical asymptote is this. What you do is you would graph the denominator. So that's what I'm going to do. I'm going to put in the denominator. Go ahead and do this. You can just erase the graph that we already did because we're done with that. So that would be x to the third minus x squared, and then plus 1. Like that, just grabbing a standard window. And what we're doing on this is we're trying to see where that's equal to 0. So see, this thing is equal to 0 one place. So what you do is you do the 0 command. Okay, you go second trace. And we've done these different commands before. Then you go down to the one that says 0. Okay, that will find that X-intercept for you. So you type in 0. A left bound just means use your cursor key until you're to the left of where that 0 is. Press enter. Use your right cursor key to get to the right of it. Okay, when it says guess, press enter. And what comes out is your vertical asymptote. So you would end up getting on part B, x equals negative 0.75 if you rounded it. Okay, like that. Okay, there are times when you have a vertical asymptote, but the only way to figure it out is with technology. Okay, if you were in the older world, you would probably use something we call Newton's method to figure that out. But that's how we're going to do that, use technology. Okay, so I wanted to do one problem that's kind of got some complexities in it, just to kind of get an understanding of how that stuff goes. The next problem, all I'm going to do is just put it in the calculator and show you what happens. And then we'll just roughly start a little bit into 3/6. But this one we're not going to do anything on. Okay, I just want you to put this in your calculator. So let me ask you a question on this while I'm putting this in. Does this have an oblique asymptote by looking at it? Yes or no? No. How come? The degree of the top is 2 bigger. Now, hopefully this one will work out the way I want you to see it, because it's kind of cool the way this one works out. And I'm not going to have you do a graph or anything on this one. It doesn't matter. I just want you to do this on your calculator. Okay? Standard window. Okay. Yeah, that's what I kind of thought would happen on that. Okay. So what happens on this, what I want to kind of explain on this is, and I think on this one, I'm not sure what that, if you did long division on this, you would end up kind of getting something like, if you did long division, well, if you divided those two things there, you would get 2x to the second. Okay, you probably would have another term in there somehow. I'm not sure exactly how that goes without doing this, but what would happen is you're going to find that this approaches that parabola. All I want you to do is visually see if you can see this. So doesn't it kind of look like, if you go this way, doesn't that kind of look like a parabola? And if you go that way, doesn't that kind of look like a parabola? What would happen on this if you did the long division is you would have something kind of like this. I don't know what the constant term would be on this exactly, but if I put in something like, I know that 2x to the second would be a part of that asymptote, then it might be something like, I'm just sort of guessing, something like that. Okay, that's not quite right, but what would happen is it would approach that parabola, whatever it is. I just wanted to show you that. Okay, you're never going to do that, but just that's something that can happen. Okay, all right, any questions? Okay, rational functions aren't too bad. I mean, you can use your technology on the harder ones, but I think, some of you definitely going to